Good morning or good afternoon, depending on where you're listening from. And welcome to TME Presents, the lessons learned from the Shiplift Expansion at Coast Guard Yard. You've read the article, and now learn the rest of the story. I'm Daniel Wheatley, editor for the Military Engineer, and it's my pleasure to welcome you all here today. Before we get started, though, I'd like to go over just a few items so you know how to best participate in today's event. All attendees are in a listen-only mode for the presentation. You can use the chat pane, though, to chat with your fellow attendees. Let's try that all now by typing in where we're listening from today. For me, it is a overcast and going to rain in a little bit here in Northern Virginia. You can submit questions for our presenter at any time by using the questions pane in the control panel. I'll collect these and address as many as we can during the Q&A session at the end of the presentation. You can please also submit any technical issues you may be encountering here as well. Originally published in the May-June 2022 issue, the lessons learned from the Shiplift Expansion at Coast Guard Yard covered a heavy construction project at Coast Guard Yard in Baltimore to expand the existing land-based transfer platform to accommodate a third rail, increasing the shipyard's dry dock capacity by 30%. Delivering this project, however, required a close coordination with ongoing base operations, navigation of antiquated infrastructure at the century-old shipyard, and adapting to changing circumstances. Before we get started with the presentation, though, we have two polls just to see who all is out there listening. So for the first one, everybody, we're interested to see who else is listening and what sector do you currently represent? Are you with a small business, medium or large business? Are you government with the military or a civilian government employee? Or are you with a nonprofit or retired? And we'll just keep that open for a little bit longer here. See, we've got a good mix here so far. Some small business, some medium, some government military, some civilian government. All right. Thank you all for being here. And then the last of our polls here, just to see what would describe your best, your current job function? Architect, an engineer of any specialty? Are you in the construction, program, project management, business development, executive leadership, or something else? See a lot of engineers representing in here, some construction, some executive leadership. We'll keep this open just a little bit longer as people come in here and we get some more replies. And we'll close that out. So yeah, we've got 67% engineers, 17% construction, 17% executive leadership, about a third of you from small business, 17% from medium businesses, 17% from military, and another third, 33% from civilian government. Thank you all for being here. And with that, I'd like to introduce the author of the article and today's featured speaker. Lieutenant Commander Avery Weston assumed the responsibilities of Executive Officer of Coast Guard Base San Juan in June of 2022, having just completed his tour as the Assistant Facilities Engineer at Coast Guard Yard in Baltimore, Maryland, during which he led the $26 million dry dock expansion project we'll be discussing today. He earned a Bachelor of Science in Civil Engineering from the Coast Guard Academy with high honors, and a Master's of Science in Civil Engineering from Virginia Tech. He is a licensed professional engineer in the Commonwealth of Virginia. Lieutenant Commander Weston, it is a pleasure to have you with us today, and we look forward to your presentation. Take it away, sir.
Thank you, Dan. No, I appreciate the introduction. I would just say from my perspective, the Coast Guard shipyard is near and dear to my heart. That was 3 years of my Coast Guard career spent as the assistant facilities engineering there, managing some of the construction at the shipyard itself. But I would be remiss to say, without, I guess, offering the accolades to FDCC, which is the Coast Guard Facilities Design and Construction Center, which manages all the major construction. So this project, the Shiplift Expansion, was a 26 mil ACNI or MILCON for the military, I guess, heavy construction contract award. And it was mainly managed at the FDCC in terms of the project management. From a facilities engineering, we were kind of the eyes and ears on the ground, managing some of the day-to-day operations. But so I would say from me professionally, I'm kind of the jack of all trades, master of none. But it was a great experience seeing just a heavy construction project go through the life cycle, seeing it on paper from the engineering design to the actual, I didn't get to see actual construction completion. I departed right before the ribbon cutting ceremony, but it was a pleasure to see the project go through just some of the life cycles that I'll be kind of discussing today. So me personally, I'm a civil engineer with kind of a focus on construction / project management. So not a geotech, not a structural engineer, but I would say I do have my professional engineering license, so I am able to, I guess, be at least a little bit dangerous in those realms. See if I can navigate forward. So with anything, I like to give kind of a backstory of where it all began and where it's kind of going towards. So the Coast Guard shipyard has a long history with the Coast Guard. It was actually, I guess, the originations came in 1899 when the land was acquired by the Revenue Cutter Service. So the actual Coast Guard shipyard itself outlives the Coast Guard in regards to the naming convention. Back then, it was the Revenue Cutter Service, which eventually became the Coast Guard. The land itself was also the place for the Coast Guard Academy. So I'm a Coast Guard Academy graduate, and it was the location for the training for cadets for the Coast Guard until it moved in 1910. The shipyard itself became the focus, and especially during World War II, was the mecca of kind of the shipyard industry. So, the statistics are from 1939 to 1943, which was kind of in prime time World War II. The U.S. as a whole expanded shipbuilding production by 5,000%. So we were turning out ships at a construction rate that was essentially unprecedented. However, with all mass productions after World War II concluded, this was a tremendous overcapacity and oversupply of new vessels. So the demand diminished very frequently after that. And from the 1950s and 1980s, the number of commercial shipyards and shipyards itself dropped off. And as of right now, the Coast Guard shipyard is one of the 5 only public shipyards. And so when I say public shipyards, essentially the federal government, the United States government, has these shipyards. So 4 of them are Navy, and this is the lone shipyard inside the Coast Guard inventory in DHS. This is a photo taken from essentially the 1910s, so right when the Revenue Cutter Service, so this is the Coast Guard shipyard. You can tell the nature of the build out. You can see the pier in front with the vessels moored alongside of it. This was kind of the north to south facing area of the shipyard itself before it kind of got developed. And so a lot of the development was around the 1930s, 1940s. In that regard, it was a bunch of timber piles being placed and man fill being shoveled and building out the actual shipyard campus itself. And so right now, the current inventory has 10,000 creosote piles, timber piles, building out the waterfront. So the waterfront was essentially all constructed in the 1940s, and as these mass build-outs occur, the deterioration in the life cycle is all kind of coming to a close. So that's going to be something that the future facility engineers inherit in terms of how to best plan the full recap strategy for the Coast Guard shipyard. Currently, it's employing about 500 civilian employees and 65 military personnel. So that's the current employment of the Coast Guard shipyard. There is some co-located commands. And so as a total, there's 2,200 employees from the Coast Guard shipyard. And this spans 113 acres and spans several commands. We have 3 O6s at the campus itself. And so there are a variety of high-profile visits in the proximity to DC and the Senate, Congress. There's a lot of congressional delegations that will come visit in terms of getting sites to the Coast Guard and then in terms of the shipyard itself. This is the campus circa 2016. You can see from the left to right of the photo, you can see the large floating dry dock, the Oak Ridge. And so this was an environmental nuisance that was also a piece to this shipyard expansion of the third rail. So the floating dry dock there became an issue with just in terms of stormwater discharge and the marine coatings that were difficult to clean up after the shipyard would work on the floating dry dock. And the Coast Guard essentially sold the floating dry dock to divest of the environmental liability for that piece of the shipyard. It's a very interesting shipyard. I can't say that I'm an expert in shipyards itself, but the way the shipyard operates is they have a sinker lift, which from what you'd expect is like an elevator for the ships. So the ships would drive onto this essentially elevator, and the elevator would lift the ship on these rails up out of the water, and they would be put on wheels and carts that would be tugged into position and then essentially worked on at the shipyard. And this, these dry dock repairs encompass, marine coatings, pulling shafts, pulling rudders, cutting holes in the hull itself to replace different pieces of machinery. So it's a very complex evolution of managing the shipyard and all the different pieces to manage those day-to-day operations. So as I alluded to before, the top photo kind of shows a plan view of the sinker lift. The turquoise covers there help with the winches, the hydraulic winches to lift the vessel out of the water. And you can see the white hole, the 617 U.S. Coast Guard 210, being in position on the rails and ready to be worked on. The sinker lift was installed in 1997, and the manufacturer has been out, and it's actually in fairly good condition, but with all single points of failure, as you can imagine, if the elevator goes down, essentially the vessels are stranded on the dry dock platform. So that is a risk that the Coast Guard is aware of, but in terms of as we divested of the floating dry dock, there was a need for improving and increasing the capacity for the shipyard itself. The Coast Guard So the Navy has a congressional mandate to perform 50% of the maintenance and repairs on their vessels through the shipyard itself. The Coast Guard does not have that mandate. And so the Coast Guard shipyard has to compete on price and economies of scale. And so right now, approximately 15% of the Coast Guard's repairs is done from the Coast Guard shipyard on its assets. And the shipyards are becoming more and more, I guess, consolidated, and it becomes more and more important to have the ability to execute these high-vis repairs on strategic vessels, especially in the increasing threats in the maritime environment. Additionally, as you can imagine, with the dry dock platform being constructed in 1997, it was constructed for vessels that were smaller and older than the new wave of surface assets that are coming down the pipeline for the Coast Guard. So the Coast Guard's in the midst of recapping its surface fleet, and when you recapitalize the vessels, the sizes are increasing and the weights are increasing. And so that's a issue with working on the new assets coming down the pipeline. But in order to maintain the current assets, there was a need to increase the capacity to work on to install a new third rail, and that was the focus of this project, was improving the shipyard dry dock capacity by 30%. So as I was kind of depicting before, number one, showing on the plan down view is the sinker lift. Two, you can see the shrink wrap around a vessel being essentially probably painted or hydroblasted for stripping the marine coatings. And then three is the Shiplift Expansion. That was essentially, when we say there was a third rail installed, if you look at from 2, 1 to 3, the first rail, second rail, and then third rail. I know the numbers don't necessarily correlate, but working right to left, that's kind of the naming convention of the rails systems for the Coast Guard shipyard. And installing the new third rail improves the capacity for it. So this is the shiplift. This is the timber platform that goes down into the water. You can see the rails there. Divers are under the water. You can see a cart kind of at the end of the pier there. So as it goes down, the cart's in place. The vessel, there's divers underwater, and the vessel essentially drives into the contained environment. And it's a slow evolution. Probably takes 4 to 5 hours to raise a vessel out of the water, and being able to then be pushed on these carts into position. Think of it like Tetris, where you put one block or where you put one vessel impacts your ability to shift the vessels around. And so it's a carefully managed game of managing timelines and when vessels can be placed in position for different operations. So you'll see essentially the rails here on number 2, the left photo, the land-based transfer area. This is where it kind of all begins to get tied in together, and then you'll see the demolition of the existing to pave the way for the third rail. You can see construction already going down, them demoing the swale and prepping the area for the project that I'll be speaking about. So this is a superimposed drawing schematic with the existing conditions. So you'll see the actual length is 347 feet of rail that this will be provided. So this will give us the capacity to put 2 175-foot keeper class, which is a buoy tender Coast Guard cutter, into position. It was to install the tower crane to service these vessels and provide the requisite reach to lift and move various pieces of equipment from the vessel itself, and then the hotel stations, so the power mounds, the utility lines to connect to the vessels themselves, and then you'll have various different connections to perform the work, whether it's welding gas, whether it's potable water, whether it's just creek water or steam. Those lines are running through it, and they called it a utility door as it roams around the built-up third rail. One of the also primary focuses of this project was to get the stormwater treatment into compliance with our NIFTY's stormwater permit through the Maryland Department of Environment. The copper, zinc levels that was from the water from the shiplift was in excess of the allowable limits. And so this project was to try to get the stormwater into compliance with current environmental regulations. So this one shows the two 175s on the same place, just in terms of superimposed of what the future size conventions will be for it. It's interesting to note that the Coast Guard shipyard, sits on Curtis Creek, which is within the 100-year floodplain, and in order to construct this project, there was a variety of environmental permits that were required to be obtained. I believe there was two major ones. There was the NIFTY's construction activity, and then there was a state federal stormwater management permit that were jointly managed from the prime contractor and FDCC, with Coast Guard Shipyard also kind of being a assigned member to those permits themselves. But the close proximity to the Curtis Creek and Anne Arundel Cove posed some issues just in terms of managing sediment control and managing the water that was being dealt with as we excavated into the soil. So this photo is a time snapshot of the construction going on. You can see towards the, north of the, or south of the photo, so towards the end of the construction site, there was a sheet pile bulkhead being installed to allow for a outfall to be kind of instituted as the primary outfall for for the water treatment and for testing, and just to make sure that we are not in excess of our stormwater discharge permits. As you kind of work around, you can see just in terms of up on the existing second ship rail, the kind of the tarps / shrink wrap of the different vessels that are being worked on as we're excavating. One of the challenges, or one of the major challenges that we found, was that trying to demolish / work from a construction standpoint while continuously operating the shipyard evolutions on the ships required a lot of deconflicting of work. So you can see, when they're painting a vessel and you are also demolishing the existing concrete and excavating, those jobs aren't very compatible in terms of one interferes with the other. So trying to deconflict and to try to prevent, because the shipyard is a revenue source for the shipyard itself, it requires, the depot repairs and the dry dock repairs. It's a revenue stream to the shipyard. Think of it as like a nonprofit. It has to be kind of net neutral, but there is revenue that's required to fund the different tasks So those operations are required, and then not trying to institute any delay damages or schedule delays to the construction site itself was really required a lot of close coordination. And that was kind of the project management that required a lot of involvement across all stakeholders, and required just the normal deconfliction that's occurred. Was two major evolutions are occurring simultaneously. From the geotech perspective, it was interesting that, when they were demolishing and the geotech analysis, they discovered, the three soil types on site. So you had the man-placed fill, you had the sandy silt, and you had clay silt. And these soil stratas drove the piles that were going to be installed to support the new third rail / loading platform. And so this required the engineer of record to select 18-inch diameter auger pressure graded piles. And they selected this over, essentially a displacement type, which would be the pre-stressed concrete piles. And this is due to the fact that the auger pressure graded piles can be installed in dense soils without jetting or hard driving, which impacts the structural integrity of the piles as you drive them. So that was the logic behind that, and it was interesting to kind of peek behind the curtain in terms of where those decisions are made and how it gets driven by the data. So this is more involved in terms of the demolition. You can see the concrete boxes that are in the center there, are the stormwater tanks that are being at least mobilized on site. You can see the trench to the right of the photo, which would be the utilidor, of keeping a lot of those utilities and stormwater management on the outskirts of the loading base transfer area. But you can also see, just in terms of the significant debris and construction material that's being played, you can see the Vulcan concrete mixer truck going on as there's other operations simultaneously all ongoing. This was interesting too in terms of the requirement for strict elevation criteria for the third rail. So all the rail had to be successfully tied in together. And so the survey crew was able to survey and make essentially the reference stations for driving, where all the elevations and where the benchmarks were located at. And unfortunately, I think due to some miscommunication, one of the original benchmark stations was demolished, and it was unclear where that location was, which required a kind of a duplication of or a resurvey to make sure that we were on the same elevation and everything would tie in together. So another plug just in terms of survey crew and how important that is to drive the future evolutions. And when it's a moving target, it kind of changes everything. So this is a cool, photo of the auger pressure graded piles being installed. So 290 of these piles were installed. You can tell just in terms of the construction rig that was there to install each pile itself was quite an evolution. And then you can kind of see the grout that's trailing behind it that gets injected. You can see kind of in the dirt there, the rebar sticking out for the tie-ins to the concrete or the beams and structural support. So get ready for the tie-ins. You can see the mass concrete get in place towards the end of the construction site. I believe that's for the pile cap, or the pile cap back down there. So this is part of the rebar cage is being built to build up the platform itself for the beams and pile caps. You can see they are building out, and then you can also see the utilidor along the edge of the outskirts of it, and you can see the rebar sticking out, the epoxy coated rebar. The close consideration with the shipyard operations just was, a constant evolution of making sure the operations conform with each other as time went on. But it was awesome seeing just in terms of the rebar and the amount of steel that's being placed and the professional nature of, just the workers, tying up rebar and connecting it all together. I was impressed seeing that hands-on, workmanship. So the mass concrete pours, it was a continual evolution, and as you kind of built it out, the contractor, made sure there was requisite crew members. Oftentimes when working with concrete, the cure time is you're racing against the clock. And with this being executed in with the shipyard operations and the volume of concrete trucks that had to be put into place, it required essentially working some graveyard shifts to ensure the concrete trucks were available and not interfering with operations. And so oftentimes the construction workers would be working the graveyard shift in terms of like 05 until 10 o'clock for the concrete pour in order to allow shipyard operations to have access to some of the locations as the concrete, trucks require washout. And we ran into, I think, one or two issues with truck drivers not being available. This was kind of during prime time of material shortages and just in terms of labor shortages. And so there was some impacts in terms of just availability, but nothing that was not able to be overcome. I like this one because it shows in terms of the deck being kind of in place while others are being kind of false work being erected for the other pours that will be going down. And it also depicts just in terms of how close in proximity all the operations are. You can see essentially a man lift from the Alder, one of the vessel that looks rusted, that got kind of it had the marine coatings stripped out of it. You can see the main lift right there. It's kind of peeking into the construction site, and you can see the two concrete trucks pouring into the concrete trucks in terms of the mass pour, and then you see the other operations all ongoing. Real estate was limited. There was kind of one way in, one way out, and so working in close proximity was kind of the nature of the game for success. So this is kind of towards the end of the third rail. You can see the rail is not actually in place, but you can see the rail pockets and the anchor bolts tied, or the anchor bolts popping out there. Weather was an impact for the concrete rail, so in order to install the requisite grout and epoxy cure, it required very finite temperature and no, water intrusion in the pockets. So the window opportunity to install that was very specific, and there was an emergency dry dock that required some operations to be kind of fast-tracked for the contractor to install to make it available to move them. But when the springtime kind of hit, the contractor was able to accelerate / expedite the operations based on Mother Nature having requisite temperature. However, it was also a race against the clock when it came to rain events. This May showers bring April flowers, or however the adage goes. That was kind of prime time for when there would be rain events quite frequently, and I think we would have to wait 2 days for the rail pockets to essentially dry out after a rain event. And so, it was a race against each rain event, and how sporadic that occurs required some things out of the control of the Coast Guard and the contractor itself. You can also see towards the right, the blue tower crane platform there. So that was kind of the foundation for the new tower crane that's going to be installed to service the third rail and provide shipyard operations to it. So unforeseen site conditions. So this was, with every geotech or, project digging in the dirt, there comes an issue where you either hit something or something happens that's unforeseen. So in this photo, it depicts one of the steam lines ruptured a hydrant and essentially flooded out part of the construction site. And this, of course, occurred around 0200 on a Sunday when everyone's off, and the ability to secure the water, execute repairs, just required some close considerations between the facilities. But it was never a dull moment in terms of managing everything that was ongoing, and what happens in the middle of the night affects you the next day. But it did also indicate, just in terms of the conditions of the existing utilities and the existing infrastructure compared to the new construction. You can see here, this is some of the repairs that were done for the tie-ins. So the steam line was depicted to tie into just an existing steam line, but the steam line was disintegrated and required to be kind of backtracked to the steam pit itself, which required some additional excavation, additional linear feet of steam to be repaired. That was a modification that we had to execute due to unforeseen site conditions. So it's all heavy construction projects, and in a area that's fairly old, there's a high risk of experiencing conditions that are unforeseen, and this is just one of them to depict that conditions that we experienced. But from a engineering drawings, you can see just in terms of all the utility lines that are in and around the vicinity of the construction site. So from the red lines, that's just showing the steam line that needs to be kind of backtracked to a steam pit by just tie into the existing line itself. And then the drawing depicts, you can see the black as the new bulkhead for the third rail for reference. As I alluded to, the stormwater treatment system was kind of the most, from a facility engineering perspective, like that was the most exciting / beneficial in terms of trying to get environmentally shipyard up to code and up to, I guess, regulatory compliance, and even exceed the standard itself. So as you can imagine, removing the marine coatings to the ships requires, stripping some heavy metals. This is, some copper, zinc, and total nitrogen and total phosphorus, and total suspended solids is something that's very strictly managed and regulated from the Maryland Department of Environment. So these contraptions will enable the stormwater to be treated in a manner that allows it to filter out the heavy metals. You can see there's some cartridge inserts. They call it the pre-treatment jellyfish, and so as water goes down through it, it moves these cartridges ups and down to remove some of the metals, heavy metals that impact the water quality. It's not lost on us that, from the Coast Guard's 11 statutory missions, marine environmental protection is one of them. So it's important for the Coast Guard to model the behavior for becoming a very environmentally friendly shipyard, especially when you have shipyards that, the stereotypical shipyard is not necessarily environmentally friendly. And so I think trying to pave the way or be the model for that is very important for the Coast Guard and for the Coast Guard shipyard itself. So this highlights in terms of how that water treatment will play out. So manhole 1, so the top MH1 that you see up there, that's the existing outfall that existed for the old land-based transfer platform. With the new third rail, it would shift the outfall down to the end of the stormwater treatment drain. So essentially, it would close up that manhole and force the water to run through the stormwater treatment that's existing for that platform. You can also see the hydroblast tank is highlighted. So during hydroblast operations, which is when they're stripping the marine coatings and takes out the paint, that concentration is so high that it would just flood out the robust stormwater treatment media, cartridges, the jellyfish, and it would essentially clog it up. So the holding tank, so essentially the hydroblast tank is a holding tank for that, any sort of liquid or the excess water that's remaining from those operations. And then that would be pumped to a truck for offloading. And there's a valve which would divert where the water would go, whether the water would go to the hydroblast tank or the stormwater treatment area. And that's based on the operations. So the shipyard essentially would open a valve, close a valve, based on if they're doing hydroblast operations or not. This is a little bit of more of a peek inside the curtain of how they're all playing together for the stormwater treatment. Essentially, this is downstream of the hydroblast tank. Hydroblast tank is pretty self-explanatory, but this just depicts in terms of all the various ins and outs of the stormwater treatment that takes place as the water goes through the process of being treated. So this slide kind of shows a profile of the manhole 1 that the contractor was shifting to the new outfall. There was an interesting piece of the puzzle where this was towards the end of the project, and essentially it was just capping or installing a check valve to move the water to the requisite location and prevent inflow from the Curtis Creek into this manhole. But water intrusion kept coming even as they capped essentially every known inlet to this manhole, and it became kind of a mystery of trying to figure out where this mysterious water was coming from. As you can imagine, it's kind of like chasing ghosts. Everyone has an opinion, And as you kind of drill through the troubleshooting of figuring out which area it was intruding from or which way it was stemming from, led to further analysis for it. But eventually it was solved, and they were able to install the check valve, and I think it was a success, but it just required some additional troubleshooting. This slide just kind of depicts the rail and the elevations that were required. So you can see all the rail elevations at 12.5 plus or minus here and there, but you can see just in terms of the margins of error of trying to keep it all level and plumb is very important. From the crossover plate, so the bottom right of the screen shows the crossover plate detail. This just indicates how the carts can move north to south, east to west, and so at these crossover locations, the rails and the wheels of these vessels can shift and move them left to right, north and south, kind of like a Tetris for a vessel into the resting place of the vessel to be worked on. So this was a snapshot of some of the planning that would go on in terms of trying to address various options. You can see from a shipyard perspective, there are some timelines in terms of when we need to undock, which would be essentially, moving the sinker lift up and down, docking vessels, and the time frame for when those vessels would be sitting on the land-based transfer itself. You can see just in terms of the red line where the construction fence lay, and just the appetite for any sort of real estate to assist in accessing these vessels and moving them. And when we were doing the final rail install, as you can imagine, tying the old rail into the new rail, it required taking that rail offline for those periods. And so, if a ship slipped to the right in terms of its schedule was delayed based on work completion, it can domino into all sorts of varieties of headaches. But it does show in terms of as we were working to get the rail installed or tie-in correctly, the close consideration it required between all operations. So this is a tower crane. You can see on the right screen, this is the elevations that were shot from the engineer in terms of ensuring the survey analysis had the requisite plumbness, because the crane itself was 129 feet tall. And so any sort of elevation difference between the foundation of the crane played out as you extend it up into the sky. This was also one of the issues we had originally. So the original RFP for this project had a generic crane that was used as a basis of design. When it became known what crane was going to be procured, it was different than the basis of design, which required some additional engineering calculations. And it was interesting from my perspective to see a crane that was manufactured in Spain but was being sold through an American company, and trying to translate all these different metric dimensions into SI or vice versa. And also it was, I guess the crane itself was normally designed for like construction crane, and so seeing the actual material, it made you kind of understand the modern marvel of some of the materials that are used for crane construction, because from a layman's perspective, it didn't look like it would withstand the weights and loading that was going to be induced onto it. And in terms of tying in where responsibilities end and when responsibilities go, in terms of, the foundation was installed from this prime contractor, and then the crane manufacturer would come in and install the rest of it. But in terms of placing various locations of where the elevator would be for the crane and where various items were, it's kind of lost in translation when you had a Spanish company that was the manufacturer. And in terms of the major lessons learned, I know it's trite, but communication is always the bread and butter of a successful project. I think as people get to know each other and you figure out how we can get to win-win situations and being proactive with communications, I think is the nature of being successful. It's always, you always say communication, but when you're in the environment of a heavy construction project, that is, a lot of money, and then you also have shipyard operations, and it's almost like, two bulls going head to head, which one budges a little bit. And I think trying to get away from a win-loss scenario into more win-win scenarios is very, very vital for project success. From a FDCC perspective, there was a lot of representatives that essentially guided the project to success. I think from my perspective, I was just kind of a tag along, eyes on the ground. But the power players really were at the prime contractor, and then in terms of the Coast Guard's FDCC, I felt like were instrumental towards the success of the project. And I found the project very informative, just in terms of seeing a project go from design development to essentially project completion, and seeing that life cycle is something rare from a military engineer, and I found it very valuable to my professional development and just in terms of education. So with that, I'll pause and see if there's any questions from the group.
Absolutely. Thank you so much, Lieutenant Commander Weston, for that presentation, and thank you for going so in depth on this really fascinating project here. Just a word here to our audience. In the handouts tab here, the slide deck and the PDH certificate is now available for download. If you want to take a look at any of those charts or graphs or anything else in more detail, you can grab them from there. And of course, your PDH certificate, make sure to take that as well. So with that, we're going to open it up to Q&A. If you've got any questions, go ahead and put them in the chat there, and we're going to get to as many as we can. There's one in particular that I wanted to start with here for Lieutenant Commander Weston. So in the issue of TME that this originally published in, we also had, as part of our engineering service reports, a report here from a rear admiral list with the Coast Guard, of course, and talking about some of the overall main efforts happening across the Coast Guard in engineering. And of course, one of them was she writes about 5 new seagoing classes for seagoing cutters, and really the modernization of the fleet, both in terms of course, this project increasing the throughput, but also making sure that you're able to support future operations and maintenance needs for these modern cutters. So what sort of considerations were made for that in this project?
Yeah, no, good question. So in terms of this project itself, it positions the Coast Guard to give it the volume, like you alluded to. The dirty secret is that in order to get some of the larger vessels to the Coast Guard shipyard, which is going to be the National Security Cutter or the OPC, the Offshore Patrol Cutter, which are kind of the new classes that's going to be the future cutter fleet of the Coast Guard. It requires some additional dredging of the channel, which requires close, coordination with the Army Corps. And so that's the restriction to get to that end state. There are initiatives to try to get that to the Coast Guard shipyard because it is such a valuable service to be on the new acquisitions. So large Coast Guard from a strategic perspective, like there's a lot of plans going down to get that end state. But from this project itself, we're hamstrung by the dredge depth of the channel. And then there's also some additional retrofits that would be required to be done on the synchro lift. And so the synchro lift itself, I forget what the exact long tonnage requirement is to lift the vessel, but there is some retrofitting that would be required to allow the winches and the hydraulic winches to lift the requisite weight out of the water. So it positions the Coast Guard to handle the volume of some of the older classes, and with the newer classes, a bit of time relief because they're newly constructed, don't necessarily need to dry dock them right away, but it is a little bit of a race against the clock to get to a position to service those vessels. New vessels, I should say.
Right.
I do see Mr. has two questions. So one was, did you have any challenges with construction site security? So 113 acres, Coast Guard shipyard, there's, a variety of stakeholders. But in terms of security itself, so the security at the Coast Guard shipyard is operated through Rapid Gate, which is a vetting resource where the contractor would get, background checks on the security themselves. We didn't have any major, security issues. There's the normal ones where, workers would want to be coming on site and they wouldn't be on the access list or have a valid background check. I think one worker had their car searched and there was discovery of drug-infused edibles, which required them to kind of be turned away. So nothing too extraordinary, but in terms of those are kind of the ones that stick out in my mind in terms of security issues. I think the hard part is from a industry perspective of jumping through all the hoops to get the background checks, to get the access for the workers to the military site. But besides jumping through those hoops, there was no issues per se. And then I also see the question of, was it a traditional design bid build or design build project? It was actually design bid build. And the interesting piece to this project was it was FY16 money. So, 6 years ago is when we had money to fund this. And so you kind of probably look at some appropriations law and you see that usually the flavor of money lasts for 5 years. This project was solicited once with kind of a more robust scope, and that was essentially what the designer advertised we could afford with the money we had. However, the requirements to try to not impact shipyard operations, you can imagine, to keep shipyard operations not impacted at all from the construction, was essentially it blew the bids out of the water. So that was a design bid build, but it was kind of a hybrid design bid build where after the bid bust to the original design, they required some retrofitting of the original design into a more affordable option for the construction project.
Thank you. Any other questions from the audience? I'll give it just a little bit longer here, all right. Well, it doesn't look like we've got any more questions, but we are just about at time here. So I think that'll be it. So, on behalf of SME and the military engineer, I wanted to thank you, Lieutenant Commander Weston, for taking the time to, present here with us. And then thank, of course, all of our attendees here as well for listening in and attending today's webinar. If you're interested in submitting an article to the military engineer, please feel free to visit our website. It's got our editorial calendar. and guidelines for riders. You can see here there's some upcoming issues here for March, April, May, June is what we're currently looking at article submissions for, but we are open to any and all topics of interest to our readership. So feel free to take a look and submit your best topics to us for consideration. So before you go today, please make sure to download your PDA certificate from the handouts tab and the slide deck as well, if you'd like to take a look at anything that Lieutenant Commander Weston has discussed in more detail. So on behalf of SAME, the military engineer, and our featured presenter, thank you all for being here and joining us today, and have a great rest of your day.